This is a presentation of civil engineering at San Francisco State University. To start with, we have 5 focus areas at San Francisco State within the program of civil engineering, and those 5 areas are structural engineering, geotechnical engineering, construction engineering, environmental engineering, and transportation engineering. So, what is civil engineering and what are the roles of each discipline? Well, I'm going to explain it based on a typical project that might be done, and I'm going to use the example of building a stadium or arena. So, here's a recent project that was done in San Francisco, and this is the Chase Center for the Golden State Warriors, and you can see the picture of it in the bottom right. Now, how does a project like this begin, and how is it completed? That's what I would like to describe, and then the roles of the various civil engineers in this type of a project. Now, it starts with generally a wealthy person or a company who is the owner of the project, and you can see in the top left we have Steph Curry, and he is talking to the owner of the Golden State Warriors, Joe Lacob. Now, Joe Lacob is a guy, for instance, I'm not picking on him or anything like that, but he is very wealthy. He made his money in the tech industry, and he wants to build a new arena for the Warriors, but he doesn't know how to build an arena. He doesn't know anything about this. So what does he have to do? Well, he starts with an architect. And an architect will put together drawings and models, and he'll talk to the owner and try to get a feel for what the owner wants. The owner is the boss. He has all the money. And like I say, that owner could be a company, it could be an individual. And the owner makes the decisions. Now, but with the help of others. And so, in this particular case, I'm showing 2 different designs of arenas, one on the left, one on the right. And, the owner could say, for instance, all right, I like this part of the one on the left and I like this part of the one on the right. Let's put it together and go back to the drawing board and show me something that's a combination of the 2, for instance. There's a lot of back and forth, and the owner, for instance, will say something like, okay, I want 100 restaurants, I want seating for 50,000 people or 20,000 people or that sort of thing. And, I want an atrium to welcome people and this and that. And the architect comes up with initial drawings of something of what that might look like, until he gets, sort of agreement with the owner and says, okay, this is what I like. So let's try to make this a reality. Now, in the process, it's not going to be exactly that, but that is the idea. That gets the whole thing started with a vision. Now, the owner and the architect, they need structural engineers at this point. Why? Because while they have the drawings of what the whole thing is going to look like, they need someone to say, okay, this is where the columns need to be. This is where the beams need to be. And they need to say how big the columns should be and how big the beams should be and how they're arranged and connected. And here are a couple of examples, one with steel on the left and the other with concrete on the right. And the structural engineer's role is to produce detailed drawings of exactly what the beams and the columns should be, and the actual structural support for this system. And in order to do that, the structural engineer generally performs a lot of computer analyses, and And so they do a lot of computer work. And in addition, they write reports and they meet with clients. And so, a structural engineer, if you end up becoming a structural engineer in the field of civil engineering, then you're going to spend time doing analyses, meeting with clients, writing reports, and generally it's pretty much office work. You might go to the site a little bit, but that's not a major part of the work of a structural engineer. So, structural engineer within the field of civil engineering is someone who works in an office and does calculations and writes reports and that sort of thing. But the end result is they determine what the structural support system will be like for the project, or in this case, an arena. Now, the building needs a foundation also, and that you have to build a support in the ground, essentially, to make sure that, in this particular example, you don't want to build the Leaning Tower of Pisa that, had a bad foundation. And of course, there are many examples. There's even something nicknamed the Leaning Tower of San Francisco. You don't want to produce that, and so as a result, you need a geotechnical engineer to design the foundation, what's below ground. This is the part that you don't see on a typical project, and you may hardly even know that it exists, but quite a bit of effort goes into determining the foundation for such a structure. And the geotechnical engineer is one who takes soil samples, brings them back to the laboratory and tests them, for instance. That's one of the roles. And you can see a drilling rig on the left there, somebody standing next to it, the driller, drilling holes into the ground and bringing up soil samples in the middle, and then those soil samples get back to a laboratory and they are tested. And that determines the soil properties so that the geotechnical engineer can design the foundation. Here are some examples of what the foundation looks like, where you have a pile foundation on the left, and you see what are called footings on the right, and where the columns have to connect to the ground somehow, and they connect through the foundation, and that's the role of the geotechnical engineers to design that foundation. Now, you have to determine how much the building is going to cost. That's the role of the construction engineer. Generally is the one who puts together, from all of the plans and drawings and all the information that has been done, that has been produced by the structural engineer and the geotechnical engineer, and then they also deal with plumbing and heating, and so electrical engineers and mechanical engineers are involved in this also. But all of their information has to go into the plans, and the construction engineer will estimate how much it's going to cost to actually build this structure. And that's one of their roles. The other role is that the construction engineer is the one who gets it built. Somebody has to be the one that is on the site and says, okay, we need to bring in concrete, we need to bring in steel, we need to do the foundation work, we need to move soil around, and we bring in the electrician and the plumber and all that stuff. And frequently the construction engineer will be on site, living or working out of a trailer on the site. And so the construction engineer spends a lot of time at the project, as opposed to a structural engineer is in the office, their home office, which may be, their home office may be in New York and the building may be in San Francisco. Whereas the construction engineer has to be right in San Francisco doing the work on the site. When they estimate their cost, they may be in New York, but eventually somebody's got to be on site to direct the project, and that is the role of the construction engineer. The environmental engineer is one who, this is a little bit aside from the project, if there is any pollution at the site, one of the first things that you have to determine at your site is, okay, do we have the remnants of possible pollution from perhaps a structure that was there previously that, for instance, maybe leaked oil or some other substance into the ground that has to be cleaned up, those sorts of things. So the environmental engineer would get involved in this type of a project by determining what pollution might be there and then cleaning it up, getting rid of it. The environmental engineer, now this is off, now we're done with the arena discussion, and the environmental engineer is also one who works on designing wastewater treatment plants, also water treatment plants, wastewater treatment plants. And so they also, and sometimes they work at a wastewater treatment plant or a water treatment plant. So the environmental engineer can spend time at the site. They can work in their office designing these plants, and sometimes they actually work at the plant. So a mix from the environmental engineer is not generally just plain office work. It could involve field work. It could involve lab work. It could involve working at a treatment plant. Transportation engineering, well, again, that's a little bit different aside. We're not on the arena. But when roads are built, they're not flat and they're not straight quite frequently. So transportation engineers deal a lot with building roads, maintaining roads, and making sure traffic flows properly. And so they plan out where roads are going to go, how they're going to be, what their elevations are, the curves are, and so they do a lot of road planning, and frequently they work for government agencies such as Caltrans has a lot of transportation engineers, and a lot of it has to do with roads, but not everything with roads, because transportation engineers deal with airports, buses, trains, bicycles, subways, pedestrians. All of that involves the field of transportation engineering, planning where these transportation systems should be, what size they need to be, what sort of traffic they need to handle, and railroads, for instance, subways, all of these things, and there are other things that are involved. Pedestrians, you can see in the bottom right, just having a pedestrian crossing, bike paths, things like that. Those are all the transportation engineers work with them. How big they should be. Even down to timing of traffic lights, where stop signs should go, etc. So, in conclusion, civil engineering has a variety of career paths, and as you progress through your career, you need to choose, in a sense, the one you like best. Now, from San Francisco State, you get exposure to all of these. You're required to take classes in all of these subjects, and so in the end, you are a general civil engineer. But you also get the opportunity to concentrate in one of those, which means taking one or two classes in the field that you like best. For instance, if you're interested in structural engineering, there are a couple other structural engineering classes that you can take to specialize within structural engineering. For instance, same thing with the other focus areas, what we call focus areas. Now, taking classes in civil engineering in San Francisco State, on our website is the program planning sheet. This is the first page of the planning sheet, where you simply put in your information, your name and address and that sort of thing. The next two pages are the most important. The one on the left lists all the classes that you are required to take. So in other words, you have to take all the courses on the left side, and you have to take 4 classes of your choice on the right side. So all of them on the left, choose 4 of them on your right. So the ones on the left are the required courses. The ones on the right are elective courses, and you need to choose 4 of those electives. So you can plan out your path semester by semester by choosing the courses on the left. Now, of course, this is just your engineering required classes. This does not include general education. So I do not have on this sheet, I don't do general education advising. This is for just civil engineering advising, that I can help you with these classes. General education, you have to go to a different advisor. But you can see the required classes. You have your chemistry, math, and physics in the top block. The second block are the lower division classes, and they can consist of your 100 and 200 level classes that are required. And then the bottom classes are the upper division classes, your 300 and 400 level classes. And then you have your senior project, which is 696, 697. Now, what you need to do is in your last 2 semesters, so your senior year, you have to make sure that you are taking your senior project. So you take your first half of the senior project, 696, in the first semester of your senior year, the 697 in the second semester of your senior year. So you just need to make sure that you plan it such that you take 696 2 semesters before you graduate, and in 697 the semester that you graduate. So we just want to make sure that you get those classes in that order, so you don't get your graduation delayed by not. You don't want to take 696 in your last semester, because then you have to stay for an extra semester to get the 697. You can't take them both in the same semester. They are in sequence, one after the other. So just make sure that you plan your schedule such that you take those in that order in your last 2 semesters. Now, if you are transferring, this is the last page of the planning sheet, and you simply list the courses that you want to transfer. The program head needs to approve those, and what you do is you fill out the last page of the planning sheet and then submit it to the program head, which is me, and you submit it along with your transcript from your transfer institution or institutions. Sometimes there are several transcripts. And I go through those courses, and I go through the approval process once I sign off on these. So you fill out this page, and I sign off on them, and then you get your transfer credits approved so that you don't have to take all your classes at San Francisco State. You don't have to repeat classes. That's the idea behind it, of course. If you have any questions of any sort, please email me, tdurrazio@sfsu.edu. So if you don't hear from me immediately, feel free to send me another email a couple days later. Sometimes I miss them. I will I'm happy to answer any questions that you have. But I do get a lot of emails, and sometimes I miss 1 or 2. So if you don't hear from me, it's not because I don't want to write back. I'm happy to respond to anything that you have. If you don't hear from me, just send it again, and I will be glad to get back to you. Okay, thank you for listening. Bye-bye.